Hello, this is the video for Chapter 5, Section 1. Chapter 5 is all about populations, and Section 1 is going to be specific to how populations grow. Remember to fill in your interactive science notes as we go, and you may pause this video at any time if you need to. The learning objectives for this section are: list the characteristics used to describe a population, identify factors that affect population size, and differentiate between exponential and logistic growth. So those are the three objectives that we are going to be focusing on in this lecture. Characteristics of populations. It starts out right away with a key concept question. The question asks us what characteristics are used to describe a population. There are three important characteristics of a population, and they are geographic distribution, that is where the population is located. Population density, so how many people or how many organisms can be stuffed into that particular geographic region. And also the growth rate, and that's what we're going to focus on today, is the growth rate. So what factors are going to affect a population size then? Second key concept question coming right at you. Three factors that can affect population size: the number of births, the number of deaths, and the number of individuals that enter or leave the population. Remember, when we speak about population, it's not just people we're talking about. We're talking about any sort of organism population. Could be bacteria, could be birds, it could be plants, any sort of population at all, and the same rules apply for population size. A population can grow when its birth rate is greater than its death rate. So that makes sense, right? The more people who are born into a population are going to increase the number of people in that area. And if there's more people who are born than die, the population increases. Immigration is the movement of individuals into an area, and this is another factor that can cause population to grow. We hear a lot about immigration in our society, in the media, and about immigration of people from other countries. There's also emigration with an E, and that is the movement of individuals out of an area. So immigration moves people in, emigration moves people out. Next key concept question is about exponential growth, and the question asks what are exponential growth and what are logistic growth. Well, for exponential growth here, if we have ideal conditions with unlimited resources, a population will grow exponentially. And that just means it will grow really, really fast. And we talk about that in just a minute, and I'll show you what that looks like on a graph as well. So this exponential growth, this occurs when the individuals in a population reproduce at a constant rate. So the individual organisms are reproducing constant, then you're going to get more people growing, then you're going to get more people reproducing. So what that does is the population becomes larger and larger until it approaches an infinitely large size. So it just keeps growing, and there's kind of no cutoff for it. This is what a chart is going to look like. We have here, this is a bacterial growth population, but this one over here is the growth of an elephant population. If you look, we're talking time versus years over here, hours versus years. The growth rate looks the same. You start out with a little bit, and they keep reproducing until all of a sudden you get this huge spike in our population. And this is kind of a little bit of a J shape here. So it doesn't matter if you're talking about bacteria or about elephants, the population is going to look the same. The graph is going to look the same when we're talking about exponential growth. The next one is logistic growth. The more and more people you get, or the more and more organisms that you get into an area, the resources are going to become less available. And during this time, when the resources become less available, the growth of the population is then going to slow down or stop. Logistic growth occurs when a population's growth slows or stops following a period of exponential growth. So you get that quick spike in the population, and then you have the logistic growth after that. This is what the curve looks like on a growth chart for logistic growth. So logistic growth is characterized by an S-shaped curve. We have this spike right here, okay? So we have growing just a little bit. We have our little J shape, and it kind of spikes up exponentially. Then what happens is it comes close to this carrying capacity. The carrying capacity is how large of a population an area can maintain with its resources. So this carrying capacity kind of gets it cut off. In this logistic growth, this part up here, everything kind of covers around that. It's not going to get any higher than that because all of the resources don't allow that to happen. Here's an example of wolf and moose populations on Isle Royale and what you see happen. So we've got the moose, which is the prey, and we've got the wolf, which is the predator. And you see that the wolf population and the moose population, that they end up crossing. And what happens is they kind of come in contact with each other. So there's lots of moose, lots of wolves, and then they cross paths there a little bit. This isn't something that we have to worry about too much until the next section, but it's just kind of interesting to see kind of the growth chart and how everything comes up and it drops off, and then the wolves jump up and the moose drop off, and it just kind of goes back and forth as to who has the higher population. Let's go over those learning objective reviews for this section. So the question is, what are the characteristics used to describe a population? Well, remember, we have the geographic distribution, we have the population density, and the growth rate. Those are the characteristics that will help describe a population. What are the factors that affect population size? 3 different factors. We have the birth rate, so the number of births, the number of deaths, and the number of individuals that enter or leave that population. And then what is the difference between exponential and logistic growth? Exponential growth occurs when the individuals in a population reproduce at a constant rate, and you get that spike really quick at the end, that exponential spike. With logistic, we have a population's growth slows or stops following that period of exponential growth. So you have the exponential growth in the middle, and then you have the logistic growth at the top where everything kind of evens out along that carrying capacity. This has been the lecture for the notes for Chapter 5, Section 1. I hope you're able to get everything down that you need. Feel free to watch the video again or rewind it, pause it as you need to, and I will look forward to speaking with you next time. See you later.